Do you ever think about what holds friendships together? It might surprise you to learn that friendship isn't just emotion, it's also mathematics. Let's explore how math helps explain what friendship really means. First, picture your friend group as a network of dots and lines. Each person is a dot or a node, and each friendship is a connecting line. Some people may have many connections and are called hubs. They're the organizers. They spread news fast and their invitations reach most of the group. On a screen, we'd circle those dots and see how central they are. Mathematically, this is called graph theory. It shows us who's essential and who links different people. You might have noticed that you became friends with people who are already kind of like you. If two of your friends also know each other, there's a strong chance the group is tightly connected. That's called a clique. And graph theory tells us it's more than just connected people. It's a fully connected network. When everyone in a group has a friendship link to everyone else, that's a clique. It's a useful way to see how strong or small friend groups form. Next, think about interests. You and your friends might overlap in hobbies like football, art, or video games. We can use Venn diagrams to visualize that. Each interest is a circle, and the overlaps show who likes what. A Venn diagram basically uses circles to depict sets of information. The more overlap, the more topics you can bond over. Extend this into written sets, which sort of define a collection of things. One set could be your schoolmates, another your art club friends. Using set operations, union, intersection, and difference, you can decide who to invite to which event. For example, inviting people who are both in your art group and friend group means you're looking at the intersection of those two sets. The union of two sets is basically a set consisting of all the elements from both sets. The intersection is the set of all common elements, and the difference is the set of everything but the common element. Let's talk about statistics. Usually, we have about 5 close friends on average. Your group might be bigger or smaller, but knowing some mathematically defined terms like mean and standard deviation gives you a social snapshot. You can visualize your friendships with bar graphs like number of close friends per classmate or time spent chatting each week. It's math, but it's also deeply personal. Mean is the average of all observations, and standard deviation is the amount of variation of a set of values from its mean. A low standard deviation indicates that the observations are clustered closely around the mean, while a high standard deviation indicates the observations are more spread out. In simpler terms, it tells you how much the numbers in a group differ from the average. Now, when you're planning an activity, like forming a team, you're using math. Suppose 6 friends want to form teams of 3. How many ways can you choose? The answer is 6 choose 3 or 20. What this means is that we're using a fun idea known as combinations. Using combinations, we can pick the total possible ways to choose something. Math helps you plan fairly, whether you're picking teams, seating groups, or rotating chores. Friendship isn't always about teamwork. Sometimes it's a strategic balance of cooperation and trust. That's where game theory comes in. In the classic prisoner's dilemma, where you have the choice to betray or cooperate, if both people cooperate, they both benefit. But if one betrays the other, that betrayer wins big and the other loses. In friendships, following a tit for tat strategy, cooperate first, then mirror your friend's last behavior, encourages mutual respect and trust. Real world friendships thrive when there's give and take. Some friends also act as bridges between different cliques. Identifying them requires understanding network centrality. Degree centrality is who has the most friends, and betweenness centrality is who connects separate groups. They show who's vital for communication. These bridge people are key when organizing events or sharing news with everyone. Friendships also change over time. Someone you saw every day may become someone you see once a month. We can model this with Markov chains, like those seen in previous videos, where each friend has a chance to stay close, drift, or move to just an acquaintance. For example, there may be an 80% chance a close friendship stays close, 15% it becomes casual, and 5% it breaks. Now let's consider trust on a personal level. What if we assign each friend a trust rating from 0 to 10? We calculate the average trust level for the group and maybe add feelings of support or fairness into the mix. If one friend rates much lower, we might talk about what's going wrong. This is like creating a friendship trust chart. This is math guiding emotional honesty. What if you want to predict who might become friends? You can collect data if you're in the same class, mutual friends, shared interests, and feed it into a regression model, which is something we use for predicting stuff. The model weights each factor, giving you a prediction. For example, you have a 70% chance to be friends with this person. While we may not implement this in real life, dating apps and social platforms use similar models to suggest friendships. Choosing a group activity sometimes leads to surprises. You might see a paradox, where Group A beats B, B beats C, and C beats A. There's no overall winner, even if most of the group preferred A to B and B to C. It means majority vote doesn't always give a clear choice, and sometimes discussions, rather than voting, produce a better decision. Consider an emotional give and take. We can think of it mathematically. Count every favor given and received. The total balance, the help you gave minus the help received, should stay around 0 for a fair friendship. If the sum keeps going negative, resentment builds. If it's too positive, you might burn out. A simple chart can help keep track and guide conversations before hurt can grow. So far, I hope you can see that friendship isn't just emotional. It's a fascinating arena where math shapes connection and trust takes form. We already model friendships as networks, where some people are hubs and bridges. But we can also measure how tightly knit a friendship group is using something called the clustering coefficient. It calculates the probability that two friends of yours are also friends with each other. A high clustering coefficient means your friends know each other and your social circle is tight. This often happens in school groups or sport teams, creating strong social support systems. Another key concept is the small world network, a type of social network when most people are connected through surprisingly few steps. You might only be 6 degrees of separation from someone you've never met. That's the small world property. It explains how rumors, trends, or memes quickly ripple through social circles. Knowing this helps us understand the speed of information flow in friendship groups. Through these examples, graph theory, set operations, probability, game theory, logical implications, network metrics, etc., you begin to see how math maps onto real friendships. It's not cold or clinical, it's practical. This is math as a tool to understand connection, fairness, trust, and change.